Hey there, folks. This is the practice chapters 1 and 2 test, and I am the amazing Mr. Jansen. So away we go. If we look at the first one is just order of operations. So we're following the old please excuse my dear Aunt Sally. And remember, we start with parentheses, then we go to exponents. Multiplication and division are tied, and so are addition and subtraction. So whichever one comes first, that's the one we do first with regards to those. So with this one, I start inside the parentheses. Inside the parentheses, I'm going to do the exponent. So that's going to be 2 squared, which is 4. And then again, I go back inside parentheses. Inside the parentheses, I've got division and I've got multiplication. And those are tied again, so I do whichever one comes first. And it looks like the division shows up first, so that's when I do first, going left to right. So 12 divided by 3 is 4. And now again, inside parentheses, I do the multiplication. That's going to give me a 16. And now 2 times 16 is a 32. Minus 4 times a negative 1/2 is going to be a negative 2. So I end up with this minus a negative, which remember is the same thing as plus a positive. So that gives me a 34. And that's it. Okay? Taking a look at the next one. With this one, I want to solve. So the idea here is to simplify and then solve. So the first thing I'm going to do is I'm going to distribute this 5. So I distribute the 5. That's going to give me a 30 minus 15x equals 5x plus 20. Sorry. And now I want to get my x's on the same side. I always deal with the variables first. So I'm going to add this 15x to each side. So that's going to give me 30 equals a 20x plus 20. I now have to subtract the 20 from each side. Even though I wrote addition there like a crazy person. Let me try again. So that's going to give me 10 equals 20x. And then the last thing I have to do is divide each side by the 20. So I find out x equals 1/2. Okay? For the next one, anytime I'm dealing with an equation that has fractions in it, the first thing I want to do is get rid of all the fractions by multiplying through by the common denominator. Here, the common denominator between 4, 2, and 8 is just 8. So I'm just going to multiply each side of the equation by 8. And when I do that, I'm going to have to do a little bit of distributing. Over here, I have to distribute the 8 to each piece. And if you need to take these off to the side to see what's going on, the first one is going to be 8 over 1 times 3/4. And again, we can cross-reduce. The 8 and the 4 reduce to a 2 and a 1. So when I multiply across, it just gives me a 6. Again, I could take this off to the side. The 8 over 1 times 1/2, just so you can see the process here. Again, the 8 and the 2 cancel to leave me with a 4 and a 1. So when I multiply straight across here, it gives me a 4. So minus a 4n equals, and then over here, this is the easiest out of all of them, the 8 over 1 times the 5 over 8. Again, we can cross-reduce. The 8's cancel out, just become 1s. So when I multiply this straight across, it's just a 5. So the effect this has is now all the fractions are gone. Now I can solve for the variable. So I'm going to subtract the 6 from each side. So I get a negative 4n equals a negative 1. Divide each side by the negative 4. And I find out that n equals a positive 1/4. And that's it. Take a look at the next one. When I have the absolute value, if the absolute value is already by itself, I'm going to split this into 2 equations. The first equation, I write this just as it was, the y plus 3 equals 2. The next piece of this I'm going to write as y plus 3 equals a negative 2. Okay? I always set it equal to what's over there and then set it equal to the opposite of what's over there. And I would just have 2 equations to solve. I subtract the 3 from each side. So on this first one, I get y equals a negative 1. Over here I have to subtract the 3 from each side. So I find out that y equals a -5. And then the last thing I should do is mentally plug this back in and check it. -1 plus 3 is 2. Absolute value of that is 2, so this one works. And then the second one, -5 plus 3 is a -2. Absolute value of that is also a +2, so that one works as well. Okay, always check them in, always plug them in, check them, make sure they work. For the next one, here the absolute value isn't by itself. And before I split this into two equations, I got to get the absolute value by itself first. So I'm going to subtract the 3 from each side. So now I'll have the absolute value of 2x plus 1 equals a -2. And now that the absolute value is by itself, this is where I would split it into two equations. However, I see the absolute value equal to a negative over here. And the absolute value can't equal a negative. So right away I can just say no solution for this one. Okay, that's not going to be possible. All right, if that wasn't a negative, this is where I would split it up. So again, remember to isolate the absolute value and then split it into the two equations. For number 6, this is like a three-sided equation. So if I was ignoring part of this, like if I was ignoring this part, and just looking at the 9 is less than or equal to 2x plus 3, first thing I would do is subtract the 3 and then divide by the 2. If I was ignoring the other half of this, I would do the same thing, subtract the 3 and divide by the 2. So I'm just going to do all three pieces at once. First thing I'm going to do is subtract the 3. And I do that from all three sides. That gives me 6. It's less than or equal to a 2x less than or equal to 10. And now I divide by 2. And again, I do it to all three sides. So I end up with 3 is less than or equal to x less than or equal to 5. And the last thing I want to do is check it on my graph. 3 would be down here somewhere, and a 5 would be up here. If I want to be bigger than or equal to the 3, I would be going this way. And less than or equal to the 5, I would be going this way. So there's overlap in the middle, which is what I'm looking for. And that tells me that I have a good solution here. Really what I'm checking for is to see if there's no solution. Okay, if there's no overlap with an and inequality like that, then there's no solution. For the next one, the or is essentially just two inequalities that we have to solve. I'm going to subtract the 2 from each side. So I get a 5k is less than a -15. And now I have to divide each side by a 5. And what I'm dividing by here is a positive, so I don't have to flip the inequality sign. It's a -3. If I multiply or divide by a negative, remember I have to flip the inequality sign. Don't forget about that. Here I've got to add 1 to each side. So I end up with 8k is greater than a 20. And then I divide each side by 8. So I find out that k is greater than, this is 20 over 8, which of course I can reduce the reach divisible by 4. So I'm going to write it as a 5/2. And then the last thing I want to do is check this. -3 is down here somewhere. The 5/2 is up here somewhere. It says I want to be less than the -3, which is over here. And I want to be greater than the 5/2, which is over here. And with the ors, we don't want them to overlap. If they overlap, it tweaks our solution a little bit. That changes it to either all real numbers, or it changes it to something like just one of my inequalities. Okay, but this tells me I have a good solution and that I need both pieces. Okay. Take a look at the next one. Absolute value inequalities, remember, just compounded inequalities. They're compounded inequalities in disguise. So I want to split this up. It's going to be an x plus 3 is less than or equal to 5. We write it exactly the way it was. And then our second piece of this inequality is the x plus 3 is greater than or equal to a -5. Okay, we've switched the inequality sign and changed the sign of what's over there. And now I just have to solve each of these. I subtract the 3 from each side. So I get x is less than or equal to 2. Over here I subtract the 3, and I find out that x is greater than or equal to a -8. And then I have to decide if this is an and or an or inequality. Since the absolute value is less than up here, it means it's an and inequality. And since it's an and, I can write it as one string. It's -8 less than or equal to x less than or equal to 2. And then the last thing I do is check it to make sure I have a good solution. Bigger than the -8, smaller than the 2, so I find that I have overlap in between. Okay. On the next one, again, I start off the same way. I split it up. I've got the 2x minus 4 is greater than 6. and then I have the 2x minus 4 is less than a negative 6. Again, I change the sign of what's over there. I flip the inequality sign. Now I have to solve each. So I add the 4 to each side. Gives me a 2x is greater than 10. I divide each side by the 2. So I get x is greater than 5. Over here, I have to add the 4 to each side. So I end up with a 2x is less than negative 2. Divide each side by the 2. So I find that x is less than a negative 1. And since the absolute value was greater than, it means it's an OR, so this is an OR inequality. And then, of course, the last thing I do is check it. I want to be less than the negative 1, greater than the 5. I don't have any overlap, so I don't need to tweak this solution at all. So each of these ended up being a good solution. Okay? For the next one, I want to find the slope, and you can either use your slope formula, or you can do change in y over change in x. I'm going to do change in y over change in x. If I look at the y values, y was a 3. Now it's a 7. It has gone up 4, so I put a positive 4 down. And then I look at the x values. X was a 1. Now it's a 3. It's gone up 2, so I put a positive 2 down. So my slope is 2. On number 11, we just have to do our rise over run. So counting left to right, it looks like I have to go down and then over. And I just have to count these up. I go down 2, there's 2 units here, and I go over 1, 2, 3, 4, 5, 6, 7, 8. So down 2 and over 8. Since I went down 2, it's a negative 2. And I went over 8, so that's a positive 8. So that's a negative 1/4 for my slope. And that's it. Moving right along, number 12, I just want to identify the x and y intercepts. The x-intercept is where it crosses the x-axis, which it crosses right here at 1. And again, that's the same thing as the ordered pair 1, 0. The y-intercept is where it crosses the y-axis, which it looks like right here at 2. So the y-intercept is 2, and again, that's the ordered pair 0, 2. Okay, and thinking about that in terms of the zeros, that's how we have to approach number 13. Remember, the x-intercept is when y equals to 0. So if I plug a 0 in for y and solve for x, that'll give me the x-intercept. And the y-intercept is when x is equal to 0. So if I plug a 0 in for x, I can solve for y. And these will give me my 2 intercepts. So I've got 4x equals 12. I've got to divide each side by the 4. So I find out that x equals a 3. And then over here, I've got a negative 2y equals 12. Again, I have to divide each side, so I divide each side by the negative 2, and I find out that y equals a negative 6. So these are my 2 intercepts. The x-intercept is 3, the y-intercept is negative 6. But again, this is the ordered pair 3, 0. This is the ordered pair 0, negative 6. Okay? Taking a look at the next example. Here we want to write the equation of the line, and the 2 things we need to write the equation of the line are the slope and the y-intercept. Since this one tells us it's parallel to this line has a slope of negative 2, and parallel lines have the same slope, so our slope is also going to be negative 2. Now to find the y-intercept, I start with a fresh y equals mx plus b, and I plug in what I know. I know that the slope is negative 2, and then I have an x and a y value right here, this ordered pair. So I plug in the 3 for x, 3 for y. Now I just solve for b. So 3 equals a negative 6 plus b. To solve this for b, I have to add the 6 to each side. So I find out that b equals a 9. So now I have the slope, the y-intercept. Now I just plug it into slope-intercept form. So it's y equals a negative 2x plus 9. And that's it. Okay, find the slope, find the y-intercept, plug it in.